Okay, let's talk some more about testing a linear restriction. Testing this can be done either with a t-test or f-test. If it's an f-test, you want to think about a t-test is just one restriction, and an f-test is one or more restrictions. So an f-test and a t-test with one restriction should always end up with the same result. So let's say I have a model and let's do something even more unusual than the homework or the one from class. Let's suppose that I think that the net effect of variables x1 and x2 together, or the sum of those variable coefficients, is roughly the same magnitude as the impact of x3. So in a story, and let's assume for simplicity to make that these are all things that we expect to have a positive impact on y. So if we thought that the magnitude of this was roughly the same as the magnitude of B3. So again, maybe we already know that they're statistically significant individually, but we're thinking about their magnitudes more so in this type of a question. So if they were all positive and those were the roughly the same sizes, then what would happen is that when I take this plus this and subtract this, then that would equal 0. So this model is unrestricted. This is just the general model. But now that I'm thinking about this, I could put this into my model and restrict it. So what does that mean? If it's put into the model, then what I could do is substitute every place I see beta 3, I could put in beta 1 plus beta 2. So let's change colors for a minute. So if I had beta 1, x1, beta 2, x2, and instead of beta 3, I put in beta 1 plus beta 2 times x3, then what we can see happening there is that it's forced a relationship so that it can only fit what's going on with x3 to be of the same magnitude as the sum of the other two. But how would I estimate that if I'm estimating separately? I would just rearrange things and I would see that, well, beta 1 is multiplied by x1 plus x3. Beta 2 is multiplied by x2 plus x3, and then I have an error term. So this is showing me how I would actually estimate the restricted model. I would just make a new variable, let's call it x13, and I would make a new variable x23. I could either create new variables in R, or I can type in the equation in R that says estimate it with the sum. But after this is estimated, you notice there was one restriction. I've estimated one fewer coefficient, and then now I have a restricted model and an unrestricted model, and I can use f-test just like I did in my video on joint significance. And I could use what's the r squared from the unrestricted minus the r squared from the restricted divided by q, where there's one restriction. What's 1 minus r squared from the unrestricted divided by n minus k minus 1. And again, this needs to come from unrestricted. So this is showing me that the f-test is comparing the explanatory power with the restriction versus the explanatory power without the restriction, and it's trying to detect if having the restriction is having kind of a minimal impact. If having the restriction is having a minimal impact, then we are going to have similar r-squareds, and we would not be able to reject the null. Oh, whoops. Do I have my null and alternative? No, I do not. Let's put out of order. So think about that up top, but I left it out. That our null hypothesis is that, let's go back to see it right here. Our null hypothesis is beta 1 plus beta 2 equals beta 3, or we can write it as beta 1 plus beta 2 minus beta 3 is 0. This would be beta 1 plus beta 2 is not beta 3, or beta 1 plus beta 2 minus beta 3 is not 0. That's what we're testing, so this is actually step 1. And then we would generate our F test. We would have an F critical that has numerator degrees of freedom of 1 restriction, denominator degrees of freedom of n minus k minus 1. And we would see if we can reject the null. So if we reject the null, in this case what we're saying, it's not true that beta 1 plus beta 2 is equal to beta 3 in the population. If we do not reject the null, then we're only able to say that we've not been able to prove that the sum of beta 1 plus beta 2 is not equal to beta 3. So let's say we have not rejected the null, just as a comparison to the other videos. Then what we would get is do not reject the null, which means we have not shown that beta 1 plus beta 2 is not equal to beta 3. Or in the context of this story, the sum of impacts of x1 and x2 cannot be shown to differ from impact of x3. Notice I cannot prove that they are equal. I can only test that in the null and prove whether or not they're unequal.